For this tutorial, we will be using the TARDIS example to demonstrate some of the masking tools that are available and how they can be used. Often you will have undesirable signals from other layers or other X-ray sources, and in order to remove unwanted signal noise, there are a variety of masking options available. To mask out noise around the edges, you can configure the panel buffer for each detector. In the instrument panel on the left side, you will find a button to do this under each detector in the tree view. If you are in the form view, you can select the detector from the drop-down menu here, and then set the panel buffer that way. Panel buffers can be set one of two ways. The first is by setting the border in millimeters. And here we can see the pixels disappear once we've set the border. You can also reset using the clear panel buffer option. The second option is to load in a NumPy file. The NumPy file should contain a 2D Boolean array that matches the exact shape of the detector and explicitly indicates which pixels should be kept and which should be ignored. To mask noisy regions that are ellipsoidal or rectangular in nature, like those often produced by other layers, we can use the Ellipse rectangle masking tool available in the Edit menu. We can find this tool under Edit, Masks, Draw, Ellipse Rectangle. When using this tool, we can left-click and drag to continue to draw and mask out regions until we've found all the areas that we'd like to mask. If you've drawn a mask and you find that it needs to be repositioned, you can left-click and drag it to move that mask around. You can also use Shift and left-click to rotate the mask. Selections can be undone one at a time. And once we have all the regions selected that we'd like to mask, we can use the OK button to complete the task. For other signal noise, like that produced by other X-ray sources, we can use the Polygon masking tool found under Edit, Masks, Draw, Polygon. With this tool, we can select a region to mask out by left-clicking to place markers as a boundary position for the region. Everything within this bounds will be masked. Once we've completely selected a region, you can right-click, and this will allow us to start selecting a new region to mask out. This will also be indicated by the change in colored markers. Once we're satisfied with our selections here, we can again use OK to complete this step and apply the mask that we've drawn. The pinhole mask is the last option that we will cover in this video. This tool is found under Edit, Masks, Apply, Pinhole. This tool allows us to mask regions that should not have X-ray diffraction information given the pinhole setup. The radius value represents the pinhole size, and the thickness value represents the thickness of the pinhole. The default values reflect the typical setup, but both values can be adjusted if needed. Now that we've applied the masking that we need for this TARDIS example, there are a few other tools that we have not covered that might prove useful to you along the way. First is the Mask Manager, located in Edit, Masks, Manage Masks. From the Mask Manager, you are able to toggle the visibility of masks, either one at a time or all at once. You can remove masks if you no longer need them, as well as rename masks if you'd like. You're also able to import and export masks to and from HDF5 files. And there's an option to preview masks in the raw view with a binary masked, not masked set of images. You may have also noticed that in the lower left corner of the dialogues that we've used, there's a help button. Using these help buttons will take you to the section of the documentation where we cover the use of that specific tool. There are even more masking tools available, so be sure to check out the full documentation linked in the description that covers all of the available options and how to use them. We'll see you in the next tutorial.